Welcome back, everyone, for another deep dive. This
Yeah.
time we're going to get into forces and pressure and how they shape our world. I'm really excited to dive into this topic.
Yeah, me too. It's gonna be fun.
It's so cool how these things we rarely think about are actually behind so much of what we experience every single day.
Yeah.
Like think about it, a gentle breeze or like a massive skyscraper, it all comes back to these basic concepts. So before we get ahead of ourselves, let's
Yeah.
break it down.
Yeah.
What exactly is a force?
Okay, so a force, we'll think of it this way. Every time you push or pull something, you're using a force.
Okay.
It's how objects interact with each other
Mm-hmm.
and how they affect each other's motion. So if you
Oh.
kick a soccer ball,
Yeah.
that impact from your foot to the ball, that's applying force.
Yeah, that makes sense.
Yeah.
And that force makes the ball
Right.
go flying.
Exactly.
But it's not always about making things move from a standstill, right?
Hmm.
Forces can also act on something that's already moving.
Yeah, for sure. Like a hockey player, they use their stick not just to hit the puck,
Mm-hmm.
but they can use it to change its direction. They can speed it up, they can slow it down.
Yeah.
It all just depends on the direction of that force.
Okay.
And how strong it is.
So when I'm driving and I hit the brakes,
Mm-hmm.
I'm using force to slow the car down.
Yeah, exactly. So the brakes create friction,
Okay.
which is a force that's working against the direction of the car's motion,
Yeah.
and that brings it to a stop.
Okay. So we talked about physically pushing or pulling something.
Right.
Are all forces like that where things have to touch? What about something like magnets?
That's a great question. So that brings us to forces that can act at a distance.
Okay.
So magnetism is a perfect example. Have you ever played with magnets
Oh, yeah.
and felt that pull or that push
Totally.
before they even touch?
Yes. And as a kid, I thought that was straight up magic.
Right. It seems like magic, but it's not magic. They're actually interacting through what we call a magnetic field. It's basically this invisible area
Huh?
where those magnetic forces can act without actually physically touching.
So it's like a real life force field?
Yeah,
Kinda. That is so cool. And gravity, that's another one of those at a distance forces, right?
exactly. Gravity is a force of attraction
Okay.
between any two objects that have mass.
Mhm.
Now, the Earth
Yeah.
has a lot of mass, so it has a strong gravitational pull.
Mm-hmm.
That's what keeps us on the ground.
Okay.
And that's what makes things fall back down when we throw them up.
So every time I trip and fall, it's just gravity reminding me who's in charge.
You could say that.
But it's also the thing that keeps our whole planet
Right.
orbiting the sun.
It is. It's doing us a big favor there.
Yeah. Okay, so we've established forces are super important.
They are.
But sometimes, I push on something really heavy and it doesn't move at all.
Yeah.
Does that mean there's NO force happening?
No, not necessarily. It means the forces are balanced.
Okay.
So you're applying force to that object,
Mhm.
but that object is also applying a force back on you.
Oh.
And because of its weight
Yeah.
and maybe friction, it might not be moving.
It's like a tug of war
Yeah,
where both sides are equal.
exactly. It's a stalemate. But forces can also work together to change the shape of something,
Right.
like when you're kneading dough
Yeah.
or blowing up a balloon.
Or when I finally make it to the gym
Uh-huh.
and try to lift some weights,
Yeah.
hopefully my muscles are applying enough force to at least slightly change the shape of those dumbbells.
You got this.
Okay. So we've talked about forces.
Yes.
Let's move on to pressure.
Okay.
Is pressure just a fancy way of saying force, or is it something different?
So pressure IS related to force,
Okay.
but it's not exactly the same thing.
Hmm.
It's about how that force is spread out over an area. So
So it's not just T about how hard you're pushing, but it's also the area of that push.
exactly. Okay.
Think about a balloon. If you want to pop it with just your finger,
Yeah.
you got to use a lot of force.
Yeah.
But if you take a sharp needle,
Mm-hmm.
you can pop it with a lot less force.
Yeah.
Because the pressure is focused on that teeny tiny point.
It's like how knives can cut
Right.
and why high heels can damage floors.
Totally.
It's all about that concentrated pressure.
Exactly. And it's not just solids that we're talking about here.
Yeah.
Liquids and gases also exert pressure.
Wait, so the air around us is putting pressure on us right now?
It is.
Whoa.
We call that atmospheric pressure. It's kind of like we're living at the bottom of a giant ocean of air.
Okay, that's actually kind of freaky.
Yeah. But it's true.
So if we're under all that pressure all the time,
Mm-hmm.
why don't we just get crushed?
That's a good question.
Yeah.
So the pressure inside our bodies is pushing outwards,
Okay.
and that balances out the atmospheric pressure.
Oh.
So it's like a constant push and pull,
Okay.
keeping everything balanced. Our bodies are tougher than I thought. Okay, let's talk about liquids again. If I go deeper in water, like in a swimming pool.
Yeah.
Does the pressure change?
It definitely does. The deeper you go,
Mm-hmm.
the more water there is above you pushing down.
Right.
And that means the pressure increases the deeper you go.
Okay, so that's why my ears sometimes pop
Yeah.
when I go to the bottom of the pool.
Exactly. So your eardrums, they're sensitive to those pressure changes.
Okay.
And the deeper you go, the bigger the difference between the pressure outside your ear
Yeah.
and the air pressure inside your ear.
So, like, is that why deep sea creatures like look so different from
Oh, yeah.
fish that live near the surface?
Yeah. So those deep sea creatures have evolved
Right.
to survive
Mhm.
the immense pressure down there. Their bodies are often a lot more gelatinous and flexible,
Oh.
and that lets them withstand that intense force.
That is so cool. It's amazing how life finds a way.
It is.
This deep dive has already changed the way I look at things, like the air in the ocean.
Yeah.
It's all shaped by forces and pressure.
Right.
It's really incredible.
It's a great reminder that, like, even the simplest things we do are governed by these physics laws.
I feel like I need to learn even more about all of this.
Mm.
Are there any examples of pressure that we see in our everyday lives?
Oh, yeah. Tons. Think about, like, hydraulic systems, like in car brakes or construction equipment.
Okay.
They use pressure to really multiply force,
Mm.
which helps us lift really heavy things.
So like a bulldozer lifting all that dirt.
Yeah,
It's using pressure to do that.
exactly. And it's not just like huge machines. Even
Yeah.
something like a syringe uses pressure
Oh, wow.
to deliver medication or draw blood.
Wow. That is incredible.
Yeah.
That's crazy. So pressure is like everywhere.
It really is.
And it's doing all this stuff we don't even realize. Okay, so we've talked about pressure with solids.
Hmm.
What about with liquids? Does the pressure change like if you go deeper in water?
Yeah, definitely. So the deeper you go in water, the
Mhm.
more water there is above you.
Right. Right.
Pushing down, right?
Right.
So that means the pressure increases the
Okay.
deeper you go.
Okay, so that's why like sometimes when I swim to the bottom of a pool,
Yeah.
my ears kind of hurt a little.
Exactly. Yeah, your eardrums are very sensitive to those changes in pressure. So the deeper you go, the bigger that difference in pressure
Okay.
between the water outside and the air that's inside your ear.
Oh, wow. Okay, that makes sense. So is that like why deep sea creatures
Yes.
look so weird compared to like the fish we see
Yes.
near the surface?
Yeah, they've had to evolve to
Right.
handle that huge pressure.
Mm.
So their bodies are a lot different. They're often more like gelatinous, and that lets them survive that crushing force.
Wow, it's crazy how life finds a way.
I know, it's incredible.
So we were talking about air pressure earlier.
Right, atmospheric pressure.
Yeah. So like, are there other examples of that in everyday life?
Oh, yeah, for sure. Like think about when you're drinking from a straw,
Okay.
you're actually using atmospheric pressure
Oh, yeah.
to pull the liquid up the straw. So you suck in air,
Mm-hmm.
which lowers the pressure inside the straw. And then the higher atmospheric pressure outside
Yeah.
pushes down on the liquid and forces it up into the straw.
Wow. That is so cool. I never would have guessed that.
Yeah, it's pretty
Yeah.
neat. Oh, and another example. Have you ever tried to open a jar?
Oh, yeah.
That's really stuck.
Yes, all the time.
That's also atmospheric pressure at work.
Really?
Yeah, so sometimes there's a difference in pressure
Okay.
between the inside of the jar and the outside air,
Mm-hmm.
and that difference kind of creates like a seal that makes it really hard to open. But if you run the lid under hot water,
Yeah.
that can help to like equalize the pressure and make the jar easier to open.
Okay, so it's like tricking the pressure to work for you?
Exactly.
That's amazing. I'm going to have to try that next time I get a stubborn jar.
It definitely works.
So we talked about pressure in air and water.
Mm-hmm.
Is there pressure in solids too?
Well, yeah. Technically, any force
Mhm.
applied over an area creates pressure.
Okay.
But we usually think about it more with liquids and gases
Right.
because they can flow and change shape more easily.
Okay, that makes sense.
Yeah.
It's like they can really push back.
Exactly. They exert pressure in all directions.
So this whole deep dive has been super eye-opening.
Yeah.
I'm starting to see pressure everywhere now.
I told you. It's all around us.
This is really making me appreciate like the simple things we take for granted,
Right.
like breathing or drinking from a straw.
It's all physics.
Yeah, and it's all way more complex than I ever realized.
For sure. There's so much to learn about it.
I never thought about it like that.
Yep.
It's amazing. We don't even see it, but it's driving so many important technologies.
It is. And even in nature. Think
Mhm.
about trees.
Right.
They use pressure
Okay.
to like transport water and nutrients all the way up to their leaves.
Oh, wow. And what about like birds flying?
Oh, yeah. They use changes in air pressure
Okay.
to help them fly.
Wow. This deep dive has been amazing.
Yeah.
I'm really starting to see pressure everywhere.
It really is everywhere.
It's making me appreciate just like basic stuff,
I know, right?
like breathing or drinking from a straw, so much more.
Yeah, for sure.
It's way more complex than I thought.
Yeah, definitely. There's always more to learn about it.
So for our listeners who are like, whoa, I need to learn more about pressure,
Uh-huh.
what would you recommend?
Well, there's tons of great stuff online and in libraries,
Okay.
but honestly, the best way to learn is to like see it in action.
Yeah.
So try dropping different objects,
Okay.
see how gravity affects them, play with some magnets and feel those forces.
Yeah.
Or even just something as simple as blowing up a balloon. That can teach you about pressure.
Yeah. That's awesome. Maybe some of those at-home experiments
Right.
will inspire some cool new inventions.
Who knows?
The next big breakthrough could come from someone playing with a balloon.
Exactly. You never know.
Well, this has been another incredible deep dive. We learned so much about the power of forces and pressure,
It's been fun.
from like the everyday things to the really big stuff.
Mm.
I hope you all learned something new and maybe look at the world a little differently now.
Me too.
Thanks for joining us, and until next time, stay curious.